أعوذ بالله من الشيطان الرجيم. Bismillahirrahmanirrahim. Assalamu alaikum. Usman Sajid here, and today I will tell you about design. I will design for bit combination circuits by means of a four binary adder. So the overall problem is divided into two stages, stage A and stage B. In this stage, the stage A first, when we give an input an even number, then it convert into an odd number by adding one in the input. Similarly, on the other way, when we give the input as an odd number, the output will be same. Only difference is for even input. When we give even input, it will add one number in the even input and make it the odd output. So for in the second stage, the it contains both even and odd number. Simply, its answer is same as the first input applied as the input applied to the first stage. So whether it is the even or odd. For example, if the stage one in we apply the input of even, then as a result the output of the stage B will be even. And if we apply the input at stage one is odd, the output result of the stage two is odd. Here is an hint. For example, this is our first stage. When we apply an input 0010, this is our even. On stage one, it will add one to the it will add one to the input and become it odd 0011, and the result of second stage, the output of this it will be the input for this. And now 0010, this is the output of second stage, and this is the same as we applied the input on the first stage. Similarly, in the second case, we have the input of odd. So when we apply 0011, the first stage our output will be the same 0011, because we have saw this that at auto the output will be the same as the input. So the output is the same as the input, and here again the second stage output is also same as we apply the input on the first stage. Now I will tell you I will make the circuit on the Proteus that I now describe that. For that purpose, first of all, I select the all instruments which are needed. So I have taken all these four components in the library. Now I will place it in the Proteus sheet. So in first step, I will select the keypad, and then I will select the IC 74C922. I have just simply connected the pin 1, 2, 3, 4 to this X1, X2, X3, and X4, which is named as 11, 12, 8, and 7. The 4 with X4, and similarly 3 with X3. And on the other hand, A, B, C, and D, I will connect this with Y1, Y2, Y3, and Y4. Simple D is connected with the Y4, and Y3 is connected with the C, and so on. A is connected with the Y1. So then next step I did this that the number pin number 5, 6, 12, and 13 I have grounded this, and the 17 pin 17, 16, 15, 14 I will connect this with the our display. The 14 connected with the first one, and the 15 then second one, and 16, 17, so on. No, next I did that I have selected some more equipment which I needed, that Notcat 7404. I select also no logic toggle. No, I have placed this is 4-bit adder. This is our adder, and I have give the B1 supply. That is the actually complement of that supply coming from this A. So I have connect this with the first input, that is B1, and next B2, B3, and B4, and also with C0 I have connected this with the low input, that is 0. So this is used for adder, that when even input come it will convert it into an odd. And for this IC is used for converting the BCD to the binary number, this IC, and this is the adder. Now I will add the subtractor. Now our next IC is that it is act as a 4-bit subtractor. I will connect. I have connected this The output of this second stage is the input for the this second last stage our, that is stage B, and this is our stage A, and this is our input A. So the output of this is will be become the input for this, and I have connected this first stage with the second stage. And now the least significant bit, I have connected this with the original D. This is actually D complement, and this is probably D. So I have connected this with the least significant bit, and I have connected the remaining pin B2, B3, B4, and C0 with the C0 with the highest input, that is 1. So this complete our circuits. Now I run the simulation and check my result. And first I click the even, that is 4. 4 means the input is even. So our stage 1 will add 1 and make it odd. So stage A become odd, and our stage B will be the same as our, as we have applied the input, that is 4. So stage B is input and stage B is same, while the stage A become odd. So when we apply the uh, odd input, our stage A will become the same as we apply the input. So 5 is our odd input. We apply odd input, and our stage A will be the same, because in odd input, the stage A will be the same, and stage B will also equal to the input applied. So we applied the 5 input, and the stage B is also the 5. So next we applied when 6, that is even. So again, our input is even, but while the stage A will add 1 in our input and become 7, and this become odd, while the stage B will be the same, equal to the input applied, that is 6. So this is our circuit. I hope you like it, and mm, thank you very much for the watching. Allah Hafiz.